So good morning, everyone, and good afternoon for our uh, attendees joining from the UK and Europe. Very happy to be here this morning on behalf of Accelerate, Canada's zero-emission vehicle supply chain alliance, to bring you this webinar on emerging battery system ecosystems in the UK and Canada. Of course, at the outset, I want to thank folks for joining and recognize that there may be some double screen watching today from our Canadian colleagues, as there is a major investment being made this morning in the Honda Canada EV manufacturing plant and EV battery production facility here in Ontario, with both the Prime Minister and the Premier of Ontario making that announcement this morning. So very exciting times in the EV supply chain here in Canada, and we know in the UK as well. And in the last couple of years, we've been seeing these major investments and announcements. And that's the reason for the webinar today, to talk about how these emerging battery ecosystems in Canada and the UK can support each other, can learn from each other, and we can compare and contrast the successes and look at how to keep this ball rolling and keep moving forwards to the eventual production of zero-emission vehicles and their batteries for local consumption. I'd like to introduce our speakers. Our moderator today is Mo Kabara, a senior advisor to Accelerate, who's an experienced energy and climate professional with close to a decade of experience in the intersection of technology, policy, and markets. Mo actually spearheaded the establishment of Accelerate, Canada's zero-emission vehicle supply chain alliance, which brings together private and public sector players to leverage Canada's opportunity in the ZEV manufacturing. Our panelists today will include Thomas Bartlett, who's the Deputy Director of Faraday Battery Challenge at Innovate UK. Thomas joined Innovate UK in 2020 and is now the Deputy Challenge Director of a 610 million pound FBC, which is the UK government's flagship battery innovation program. We also have Dr. Luc Frechette, who is the co-founder and CTO of Calogy Solutions, a Sherbrooke-based company that is redefining battery thermal management for safer and longer-lasting EVs, and introducing a unique cooling technology for use in EV batteries. We have John Laughlin, who's the CTO at NGen. NGen is a not-for-profit that builds world-leading advanced manufacturing capacities, drives innovation, and creates jobs across Canada. John is responsible for setting NGen's technological strategy and advancing manufacturing and R&D investment. And finally, we have Jeremy Rathall, who's the founder and CEO of Cornish Lithium. Happy to have Jeremy here today to bring Cornish Lithium's perspective a bit more upstream on the critical minerals production that is emerging in both Canada and UK to support these battery ecosystems. So without further ado, I'm going to turn it over to Mo, who's going to lead the conversation today. Hopefully, all of you on line as attendees will be able to garner some key insights into these two battery ecosystems. Thanks very much, and looking forward to the conversation.
Thanks so much, Andrew, and welcome everybody. I'm actually in Europe right now. I was at the World Energy Congress, and I must say that I'm feeling a lot more optimistic about the transition, seeing what all the countries in the world are working on in some of the great innovation that's happening across the board, from electricity to hydrogen to EVs to even decarbonization of our industrial sectors. So I'm really excited today to be moderating this panel. As Andrew mentioned, I've been close with Accelerate for the past number of years, helping launch it in 2021. And to kind of start us off, I wanted to kind of talk a little bit about, the kind of three whys: why batteries, why innovation, and why Canada and the UK in this case. So very briefly, start off by talking about why batteries. I think most of us know at this point that electricity and electrification is going to be the backbone of the energy transition. We must basically fuel switch from fossil fuels to energy carriers that are going to be compatible with net zero. Obviously, we're not going to be able to electrify everything, but even when you look at some of the more conservative estimates in terms of how much we need to electrify, we're still talking about at least a doubling of electricity that we have today. And when we look at what are some of the applications that are going to be enabled by electrification, we see that there's going to be a very high need for storage and for batteries to be able to enable that. Unless we want to drive cars with catenary wires connected everywhere, we need batteries. And battery technology is critical to achieving net zero because it enables transportation electrification, but also enables renewable energy integration. And we are seeing growth in the battery sector over the last few years that is quite significant. But then the question is, why innovation? Why do we have batteries? We all have batteries in our wallets. We have our in our pockets. We have batteries in our laptops. We're seeing cars that have 700 kilometers of range. So the question always comes up, why do we need to innovate? But what's actually driving us back to the drawing board? And I think basically what I would say, there are three kind of categories. There's market applications or market drivers, and those are things that address actual real world issues that are currently barriers to adoption. So that could be cost, things like people want more range, safety issues. So those are that's one of the key driver categories that we have identified when we're looking at innovation. Second is environmental. We want batteries to be more recyclable, have a lower carbon footprint, use less materials or more sustainable materials. And the third thing is, as you talk to anybody about batteries, the first thing they'll say is like, oh, well, the minerals come from the Congos and it's not good and it's ethically not a sustainable or not an ethical product. So there's geopolitical pressures and supply chain pressures that are also forcing us to innovate our way out of those, or there could be potential for that. So when we look at that, we know that in Canada we've had battery technology innovations that spans over 40 years with significant contribution. And Canada was also recently named #1 in the Bloomberg New Energy Finance lithium ion battery supply chain ranking in terms of the potential. So there's definitely a lot of untapped potential in Canada. And in the case of UK, we know that even here we have with us today Cornish Lithium, which was actually named in the Bloomberg assessment on the UK's ranking. But we know that the UK has done a lot on battery innovation, and we are very happy to have with us today Thomas, who's going to speak to a little bit about some of the successes that they've had as well there. So with that, I am very eager to have this conversation with our panelists today and dive into it. So maybe I start with you, Thomas, and kind of looking at the innovation ecosystem in the UK specifically. As you see that evolve as market demand grows, and also as those innovation drivers kind of push us to kind of develop new products. Maybe you can kind of give us a high overview of what does that system look like today?
Yeah, sure, happy to. Yeah, can you hear me okay? First off, before I start talking. Yeah, lovely. Yes, hi everyone. Yeah, so those of you not too familiar, I guess, with the UK automotive industry and sort of where we sit. I think the key thing for us is that when we look at sort of the innovation ecosystem for the UK, all of that comes out of our existing automotive industry. So, the UK's got about automotive industry is worth about £14 billion to the UK. We export about 80% of the cars we produce. And it's actually our automotive industry is one of the biggest contributors to R&D in the UK. It's a really, really big part of where those all come from. And actually the way that our innovation sort of strategy has evolved has come out from a very, very close working relationship between industry, academia and government. And that really came out of something called the Automotive Council that we have in the UK, this industry-led group, which is most of the time is from the technical side of the automotive businesses, looking ahead around future innovation needs. And you track back, quite a while ago now, we're talking probably 10 years ago, the automotive industry got together, and thought, actually, we need someone to really help us support, long-term research and development, start looking at maybe lower carbon alternatives. Now it came things like the Advanced Propulsion Centre, which, kicked off by, like I said, about 2013. which is, government funded and industry co-funded, supporting late stage go-to-market R&D. That was a coming together of industry setting up a body to support that in the UK, and that's developed as we come across. We've seen the battery transition coming for a while. And what came out from, once again, the Auto Council and their work with government back in 2017 was this need to get ahead of this sort of incoming battery wave that was going to come ahead in terms of the innovation and helping what is, quite an established automotive industry in the UK transition to that and help them specifically on the earlier stage R&D, because they had the late stage R&D, they had their close to market programs, but actually on that early stage understanding, we're going back to 2017, a lot's changed since then on a global standpoint. And out of that came the Faraday Battery Challenge. So, we are a similar body, we're actually completely funded by government, but we support everything from application-inspired research, sort of from the university side. That's, on the scale, by the way, now where it's 500 researchers, 27 universities across 10 major projects. So, very, very coordinated, very intensive research focus with, I think it's somewhere in the region of about, it's in 50 plus industrial partners in that as well. So it's a very industrial sort of focused research, all the way through to early stage business led R&D supported by governments. This is grants going into CR&D. This is tailored where it's specifically supporting SMEs more. So we tend to support SMEs, 70% of their funding. Large auto goes down. And we funded somewhere in the region of about 118 million pounds worth of projects to date, and grown quite a good cohort of companies coming through, all the way through to also investing in the infrastructure. And that infrastructure comes back to something in the UK we have called the Catapult Network, which is technical centres of excellence. This is basically getting in open access infrastructure for like cell development, materials development, and that sort of thing, helping out companies and sort of taking away that capital risk that they have in scaling up. But also in our flagship thing in the UK called the UK Battery Industrialisation Centre, which is about, to date, is probably pushing north of £200 million worth of effectively gigafactory scale equipment, which is open access, ready to use. So what we try to build in the UK is like I said, sort of, I would say, research all the way through to late stage government support, but all of that has come out from industry government collaboration.
Mm-hmm. Yeah, no, that's brilliant to hear, Thomas. And we talked about this in our roadmap that we're doing at Accelerate, and we've called this one of the pillars of the roadmap is developing innovation infrastructure. So I'm really happy to hear that. Basically, that's the same language you're using as well. I want to turn to John here, who can. Yeah, John, if you want to give us a little bit of a scan or overview on Canada and some of the key trends here that you're seeing in the ecosystem.
Oh, wow, yeah. I mean, I'm one of these people kind of doing this and looking for the Honda announcement. For those in the UK and some maybe in Canada, there's been a lot of rumors this week about a massive announcement coming from Honda about a gigafactory here in Canada, rumored to be twice as big as the Volkswagen Parco investment, which is a 90 gigawatt hour factory, sort of 16 million square feet. Which came off the back of an announcement that Stellantis LG were also setting capabilities here in Canada. So, I mean, automotive industry in Canada, like the UK, it's exceptionally important. It's a big employer. 1.5 million units a year-ish. But that's, from its height in the 90s would have been 3 million units. So it's scaled back over the years. Very dependent on North America. 80% of components are traded within North America. There's very little outside that. And of course, there's a big shift towards zero-emission vehicles. With that, Canada set its 2030 zero-emission roadmap. We've got our targets for the number of sales of vehicles. It's targeted 20% in 2026. 60% by 2030 and then 100% by 2035. But we're very dependent on what's happening in the US. A number of the US targets have been reduced, almost halved recently, sort of looking at the 2030. So big picture, Ford, GM, Stellantis, Honda, Toyota. There's lots of car production here. There's lots of capabilities to transition to EV. There's as Mo mentioned, Canada's been ranked #1, topping China as sort of the highest potential to supply the EV supply chain. That's for a number of very good reasons, and raw materials and resources, critical minerals is one of them. But also Canada has a number of very high grade processing capabilities, over 50 smelters, and a strong environmental sort of ethos and footprint, and very, very clean energy. 83% is clean energy. 60% of that's from water, from hydro. So there's lots of very good reasons why Canada has that potential. Landscape wise, there is significantly less R&D than there is in the UK. A lot of the decisions are made across the border or elsewhere in terms of car production. And then in the component supplier parts land, it's dominated by 2 tier 1s. Magna and Linamar supply 25% of the components into the current supply chain, the internal combustion engine supply chain. And then if you take an engine plant as a supplier, so if you take GM and Ford engine plants and you look at the revenues from Magna, Linamar, GM, Ford, basically that's 50% of the automotive parts supply chain. So for Canada, there's a huge transition and pivot that needs to happen. There's been huge investment, $40 billion of investments and incentives. There's the manufacturing clean tax credit. So there's a number of strategic levers that Canada's pulling right now in order to look at that transition, and a really, really interesting, exciting time, I think, in Canada. And yeah, and then of course the announcement today will be interesting. So at a high level, I'll stop there because I'd love to get into all of our projects, and Luke and Calogy is one of our I'm going to let them talk about their projects. There's some really, really good projects and capabilities within Canada that can build up into that supply chain for the new supply chain in the future, as we try to weather this transition.
Absolutely. And John, while you were talking, the announcement came out, and we're talking about 32 gigawatt hours. So not actually bigger than PowerCo. So we'll see if that's the final number, but that's what I saw quickly here. So we'll get back to that because I have a few more questions on this. On this announcement and how the tax credits that enabled it can potentially help grow the innovation ecosystem and grow the battery ecosystem. But I want to turn to our UK friends here and to Jeremy this time. And I think what we're talking about here is really interesting in the context of growing a supply chain from the downstream, from the upstream to the downstream. And I think a lot of people kind of, when they think about battery innovation, they're thinking about using the usage of a different chemistry, or now we're going to be using solid state, or we're going to, try to remove cobalt from nickel rich batteries. And that is definitely one aspect, or, a couple of aspects of innovations. But what we've been trying to push is that innovation crosses the various segments of this supply chain and this value chain. And you being on the upstream side of things, Jeremy, I wanted to kind of give you the opportunity to talk about some of the work that you're doing, and specifically on the lithium side, and how innovation can really enable us to speed up the extraction and processing of these materials that we're going to need to go into the cathodes and into eventually the cells.
Thanks, Mo. Yeah, look, I think I've been looking at this transition for some time. My background is a mining engineer, and then I was an investment banker, so studying raw materials supplies from all over the planet. And as we move into this transition to electric vehicles, it's massively important that supply chain is sustainable. And I think that has been one of the things that people don't think about. It's interesting, we already mentioned a lot of people are concerned about the minerals that go into their car being funded from, say, the DRC or Congo, or coming from Russia. And obviously with the war in Ukraine, everyone's very focused on how much nickel comes out of Russia, and is that a good idea? How is that material processed? So we in the UK, I think the UK realized that it's not just the automotive industry itself. The UK is very proud of its automotive industry. It's still a very big component of the UK economy, as Thomas has already mentioned. But in the face of all the challenges, global challenges that we're going through at the moment, the war in Ukraine, the tragic war in Gaza, the everything else that's going on at the moment, the potential growingly more difficult relationship with China, how do we make sure that we have the security of supply for building these electric vehicles, and is that supply chain sustainable and low carbon? There's no point if we're pumping out carbon in producing the lithium that goes into electric vehicles. It really defeats the point. So the UK, so we started looking at the UK. I read about a long time ago that there was lithium in the UK. We have indeed found lithium in the UK, and we can extract it in extremely sustainable, low carbon manner, and it gives the UK a secure supply. It's not going to potentially cover all of the UK's needs for lithium, but it will cover a material portion of it, and it will be secure and sustainable. So, one of the questions, why batteries? Well, because this is what we need to make the transition. The only way at the moment is lithium batteries. We can, obviously, sodium's coming up, but I don't think sodium is going to really take over from lithium anytime soon. Why innovation? Because we need to extract these critical raw materials like lithium in a sustainable way. And frankly, if you think about when the lithium-ion battery was first commercialized, it's only 40 years ago. And we are effectively in what I like to call the beginning of the Bronze Age in terms of lithium and renewable age. We are just finding out how to do it, how to source these materials, how to do it sustainably. So that's really what my company is all about. I'm also on the Critical Minerals Committee of the UK government, where we think about how we're going to facilitate these vital raw materials. And we're also very proud to have attracted funding from the Faraday Battery Challenge. So that's a good example of how Thomas's organization has helped us out. Hopefully that answers your question.
Yeah, no, absolutely. Really appreciate that, Jeremy. And I want to turn to Luke, who, as mentioned, is with a company that is really working on innovation, again, not at this like chemistry level, but really a part of the battery system that is critically important on a number of fronts, including safety and other performance issues. So maybe, Luke, you can comment on this idea of like, how do we get people to see battery innovation beyond just that, battery cell chemistry, and kind of maybe give some the audience a bit of a preview of some of the work that you're doing and how you're seeing this opportunity.
Of course, yeah, thanks. It's definitely an exciting time, exciting day, in addition to an exciting period. So what we're seeing actually in the ecosystem is a lot focused on the cell, and even cell assembly, we should say. These big factories are really focusing on cell assembly. But if we take a step back, to make that happen, 40% of the cost of a cell actually comes from the cathode material. So you actually have to make and process that material. And sometimes even those processes are not always the most environmentally friendly. And Jeremy was pointing out that important aspect. So Canada, I think, is focused a lot on its assets, which are natural resources. So that it's really a strength. The minerals are there, and to put the next steps beyond that to go and to make cells. So even in Quebec, there's a few large installations that are now coming out of ground by Ford and GM in order to process materials to make the cathode materials specifically. So though that's nice to see the links between those required steps that are happening, instead of mining our materials, sending it to China, and then getting cells back later. So it's much more of a sustainable way, having this be done locally. But it doesn't stop there, right? Once you have the cells, you still don't have a vehicle. And if you want to make the most out of those cells and you want to maximize their lifetime, so you have less to recycle, less to fabricate, they will last longer. So you have more cells on the road for the same amount of mining done initially. If you want to do that well, and you also want to reduce cost, keep it safe, it turns out that what goes around and how you make a battery pack out of those cells is really critical also. So thermal management is one of those key aspects. Temperature will lead to failure of safety and catastrophic images that we've seen in the news. But also lifetime. If your cells go way too hot and you still operate them, or if you try to charge them when they're too cold, you really affect lifetime dramatically. So being able to operate and control electrically, but also control thermally, the battery has a big impact. And then finally, range, right? When it's cold outside, you lose a lot of range on your battery. If you manage well the temperature, you actually can increase that and less range anxiety for the user at the end of the day. So it's really those, Mo, you brought up these market drivers, cost, range, safety. Well, temperature actually assess those. So as part of the innovation path, we need to have all of those elements, and we have room for innovation and new solutions at the different steps. So Calogy in particular brings this new way to manage the temperature, which unfortunately is not traditional. It's not a cold plate. It's not typical air cooling. It's using the concept of heat pipes, or the operating principle of heat pipes, but making it in a form factor which is really meant for batteries and large volume manufacturing. But getting that actually into battery packs and having companies discover it, adopt it, going down this innovation path, from the invention, the product, but then adoption, that last phase requires collaboration between those bringing up the new technologies and those who can actually implement them and embed them. So the ecosystem also needs to have these opportunities for synergies. So I see actually in the UK this nice approach, which is already in place. So it's a kind of a nice strategy to allow these new technologies then to go a step further. It's exciting to see.
Yeah, thanks, Luke. As a heat transfer nerd, and I
that makes two of us then.
It's a heat pipe solution. I mean, I think this is great, and like one of the things that we've done in our battery innovation roadmap that I mentioned, it's coming out between now and end of June. We're going to be putting it out. As you look at these drivers, you realize there's multiple ways you can address them. There's enabling technologies across areas of battery chemistry, improving process, and the battery management system. And you're completely correct, is that the thermal management comes up on a lot of these key drivers, whether it's range, charging convenience, or longevity and durability of the vehicle, and even affordability and safety. So it's like there's a lot of components there that could be solved with what you're doing and what others are doing across these various segments of the supply chain. So given that this is a good segue to talk a little bit about growing the ecosystem and having homegrown companies, both in the UK and Canada, how we can really make sure that we're providing this supply chain security to be able to feed into these anchor investments and anchor plants that we're putting in both of our countries, whether it's on the EV assembly or the EV, the battery supply chain. So more downstream or more upstream from the assembly. So I want to turn to John. So John, I'm going to explain to our audiences, this is a moment here where we can talk a little bit about this Honda announcement, which is just coming in live. This is an opportunity, but there's something here that's quite related and quite timely for our discussion here today. So the announcement is, as we said, it's a $15 billion Canadian announcement. It's going to be doing EV assembly, so retooling a plant to do 240,000 a year vehicles a year, a battery plant with a 36 gigawatt hour capacity per year, then also doing cathodes with a partnership with POSCO, and then doing separators, a battery separator plant with Asahi Kasei from Japan as well. So we're seeing this kind of supply chain approach, the comprehensive supply chain approach that Honda has taken. And if we look at why that happened, so there's a mechanism that the Canadian government has announced in their budget last week, which basically puts out on the table a 10% tax credit that is additional to already a 30% tax credit for manufacturing. But there's provision there that in order to access that 10%, you need to be operating in 3 of these three of the segments of the supply chain. You gotta basically assemble EVs. You gotta make battery cells, and you gotta be in the cathode business. Or you can only do two of these, but then have a partnership, whether it's through a JV or I think they use it as minority interest in a corporation that is doing that and accessing that 30% tax credit. So we'd have to get into the legalese of it. But essentially, what I'm seeing here is that this could kind of give an incentive for these big OEMs to try to find partnerships with some of the local players in the ecosystem in order to be able to access that additional funding from the government. Want to turn it to you, John, to comment on that. Is that enough? Is that going to help? How do we actually scale some of these companies that we have, and who does this policy target, and who does it not?
It's so you've got the advantage of being able to read everything. On the side there, I think this is fantastic news, right? So there has been traditionally a bit of lack of R&D in Canada around the automotive sector. There is a number of companies here in Canada that have grown and have been given great incentives to go to the US, and companies like Novonix are one of those. So I think there's companies like Nano1, Novonix, some of the work that Flex and get through the Flexion Innovation Center in Windsor. This gives a lot of opportunity for starting to build a potential Canadian supply chain to supply. The challenge is scale. To supply facilities of that size means you have to be, you have to pass the supplier quality thresholds of these major companies. And so that's no small task. There's a reason why, the tier ones of the world are the size that they are. So there's a lot of work that needs to be done. There is so much interesting stuff happening, and Luke mentioned what they're doing. From an NGen perspective, we've been looking at the manufacturing processes, trying to make sure that we have world-leading manufacturing capabilities or new processes, new environmental processes that can give Canada a differentiator. And the Flexion facility is a good example where it's basically a manufacturing innovation center. It's funded a bit by NGen, but it's not a government initiative. But they are iterating and doing different developing different manufacturing processes. They've reduced the formation of the battery by 50%. They are looking at new AI vision systems for slurry mixing. They are reducing greenhouse gas emissions in the manufacturing of battery by 50%. Some at Nanotech are looking at the extraction of lithium with again 50% reduction in greenhouse gas emissions compared to current, or at least 50%, 26 times reduction in land usage. And then we've got a number of novel new manufacturing processes coming out for upstream for cathode, and so there's huge opportunity. These companies need to be able to scale within a relatively short time frame. So I think this is absolutely phenomenal, fantastic news. I haven't done my analysis yet to see kind of how this is going to trickle down, but certainly there's great opportunity, and it spurs me at an NGen on to continue to do what we're doing, because we're trying to build the supply chain up. And it's very hard to build that supply chain up if there's a gap in connectivity to the OEMs. We will continue now to sort of drive and build that supply chain up, knowing there's a big step forward in terms of the pull that needed to happen to sort of connect the two ends of that supply chain from a funding perspective.
Yeah, absolutely. And I would say, like, my also quick thoughts on this, given that in order to qualify, to be attractive to the OEM, the company itself has to be in a position where it's claiming tax credits from the manufacturing side. So it has to be at that scale already. So just like glimpsing this policy, I think it's great for the companies that we have that are already mature and ready to go, as you pointed out. But we need to kind of think about early stage, like the seed stage, the early stage, and the growth stage. This is why Thomas, I would love to hear from you in terms of how you've been able to support companies in the UK through the Faraday Battery Challenge, and specifically on that earlier stage of like taking these ideas, seeding them, and going through the stages of actually developing homegrown companies.
Yeah, sure. And I'm going to immediately start completely opposite end, but I promise you I'll come back.
Sure, yeah.
Which is, it's. I mean, it's all the announcements you talk about Honda, and in the UK, we've had some really good announcements, I'd say, in the past couple of years, and I would say some quite publicly bad ones in a few years before that as well. And I think you've got to do both. So you can't have everything on scaling up and homegrown your own companies without attracting in the established players. So in the UK we've got Envision AESC expanding up in their facilities in the country to support Nissan. I know we've also had a very good recent announcement from Agratas, which is the new Tata Group company, which ultimately is going to support Jaguar Land Rover in the UK, which between those two is pretty much hitting most of the gigawatt hours the UK is going to need by 2030. So that's fantastic and that's great. And you need that to give confidence to the market. If you're not hitting supply in, your automotive industry is starting to panic. And you're completely right. The ability to scale that and hit timelines, you only need to look at, it doesn't matter how much money you pump at a problem. It takes a certain amount of time to get a technology from concept through all the stages, scale it up, go through your pre-pilot, pilot, and everything else. And you can very quickly do the maths and look at, most states, these things opening are saying 2026 or 2027, especially in the UK and Europe, because that's where all of our rules of origin come in. So that's all our sort of, localization tariffs apply, to realize that most of the companies you're supporting are not going to be in that first generation of Gigafactory. It's not happening. So the question becomes, well, how can you get them ready for the next 10 gigawatt hour block that's going to go into that particular scale up session, or how do you hit the next generation of gigafactories that will come through, because these things aren't going to stop. It's going to keep on going, and that's what we're really focusing in the UK. So the way that we've structured it, as I say, is you've got to support the research, because but make sure that research is targeted. So that's why we've created something called a Faraday Institution, and that is really an independent body that is making sure that academic research is focused. Always needs to be a certain amount of blue sky, but you need a good level of the academic potential coming through, very wide scope. You then obviously support things with the, let's say, business-led R&D supported by government. And what that does is gives a really safe environment. And the key thing is, one, it gives money to SMEs, which is fantastic, because they need that. They need that to getting through their investment rounds. But actually, one of the biggest payoffs is it gives a safe space for large automotive or large tier one R&D departments to engage with SMEs in a lovely collaboration agreement, safe IP environment. If you try and approach a company without those mechanisms, you don't get to talk to the R&D people, you're talking to procurement people. And procurement people will ask you all the questions you're asking. Well, how are you accessing your tax credits? Are you ready to manufacture? When can you get your supply? And the answer to that will be no, go away, come back in a few years. You want to get in with the R&D people. And that's what that mechanism that we support in the UK really enables. So it allows the SMEs to get in with the automotive manufacturers and tier ones, find out the targets, find out what they need to do, and critically build those relationships over time. That's really, really critical. But one thing, and obviously then you need the open access infrastructure, because you need to sort of help accelerate those things a little bit when they're getting to the right point. I think a really important point as well is we're seeing the globalization of all of these companies. We're seeing lots of companies from Asia come over, and obviously some homegrown SMEs as well. It's great to get those large scale cell manufacturing CAM plants. It really matters where their R&D headquarters are. It doesn't matter if you've got a plant manufacturing in Canada or in the UK, if their R&D is still based over in Asia, or it's based in a different continent, because you're operating on the same global context. So one of the things we've done in the UK, we published a national battery strategy tail end of last year. One of the key priorities in that for us as the UK is trying to secure global R&D headquarters in the UK. So use the academic power, use all this innovation power we're getting to make sure that we're securing global R&D headquarters, because that then gives you sort of a bit of a lift for all the SMEs and everything, because then you've got all the R&D guys in the country that you're operating in. and they can really plug into your innovation ecosystem, into your R&D ecosystem, into the infrastructure that we're building, and then all of that starts working. So that's the approach that we're taking in the UK.
Yeah, yeah. No, that's brilliant, Thomas, and that's what we've been also trying to articulate, especially when it comes to these foreign direct investments that we've been really successful at bringing in, which is, as John mentioned, it's great news, it's great opportunity, but how do we make sure that we're sort of cashing out some of those benefits when it comes to actually bringing that R&D that is going to be some of the value creation in from an economic perspective, and also providing that security. So on this topic, Luke, I just wanted to ask you specifically, as part of your journey going through the kind of stages that I've laid out, what are some of the key things that have been, I would say, like obstacles in the way to make sure that you're kind of growing, and what have been things that actually supported you? I know that John mentioned that you've leveraged Engine, so maybe some examples on that would be great to hear from you on that.
Yeah, of course. At the same time, I'll bounce from Thomas's comments there, in the sense
Yeah.
that in order for the technology to have impact, you have to reach scale. So you have to be implemented, deployed at large scale for the environmental impact that you're aiming for with your through electrification, for that to happen. And that's why the biggest, this valley of death, in order to go from initial products that you have and being able to reach the point where you can manufacture, provide, and be adopted at large scale, is that very hard part there. So I must say that for the R&D, Canada has a good ecosystem which supports in many ways collaborations between companies and university, funding in order to get the ball rolling, in order to support R&D efforts. So there's a good ecosystem, both provincial and federal, to help make that happen. So Engine is an example where they'll provide us support to develop our manufacturing processes. So again, we're aiming for large scale for our deployment of our cooling technology. So we have a unique manufacturing approach, but the machine to make this, to manufacture these parts, doesn't exist in the world. So we actually had to work with partners across the world in order to come together and then to create this machine that is meant to have a high throughput from manufacturing perspective. So without support like programs like Engine, we would have had to absorb the cost of that. And for a startup, especially with the Canadian VC funding environment, which is not very as generous as in the US, well, that becomes almost impossible. So the biggest thing, I guess, doing the R&D, good support, but going from there to having a product which you can deliver in large volume and being adopted, that's the harder parts. So the other path that is really enabling and challenging is to get people to adopt your new technology. So in our case, we're lucky to work with European automotive OEMs. Like, for example, one in Germany, and their R&D group, they're open to considering these new ideas, even if it's for a vehicle that's many years down the road. So that gives us the chance to actually put it into a vehicle and look with their engineers what would be the impact on that, and have an adoption path for the project for the large scale. So I think that's probably the biggest thing missing, is how do you create this opportunity for technologies to go beyond, and other ones like John was pointing out, like Nano One, they have a process for environmentally friendly cathode treatment. But again, you'll have an impact once it's adopted at large scale. So that's challenging. You're on mute, Mo.
Yeah, speaking of large scale, I mean, I know that Jeremy, you had mentioned we need to be extracting lithium at scale if we want to be able to meet the demand that is going to be emerging over even just this decade. Like every forecast I've looked at, is calling for shortages in supply later in this decade. How have you used innovation in your company? And from some of the things that I've seen, the usage of some digital technology specifically to help with the mapping of the resources, and that can help accelerate those timelines. And then maybe also speak a little bit about some of the support that you've received, and maybe some of the obstacles that you've faced as maybe that uniquely positioned you on the upstream of the supply chain.
Okay, look, I think we've used a raft of different technologies, many of which have only recently been developed. Modeling the resource base itself, we've used technologies called GIS, which Global Information System, which really, in the form that we use it, was only been around about 8 years. And this enables a three-dimensional jigsaw stack to stack geography on geology, on ownership, et cetera, et cetera. So we've used that. We've used a lot of highly advanced direct lithium extraction technologies. We've tested over 30 different technologies globally. And this really brings me to the point where this move to electric vehicles and renewables is so important for the research community. Because if you think about the oil and gas industry, how many points that touches across universities and funding and the economy in general, we're going to be moving away from those oil and gas. I don't think we can ever move away completely from oil and gas, but we move away from it generally in terms of automotive and transportation. There is a growing body of very clever people who realize that essentially electric vehicles and renewable energy is chemistry. And that is where we've seen really innovative solutions to what we're trying to do, including UK companies who are developing membranes and ion exchange technologies to extract lithium from water, in our case, and also from hard rock. And that ecosystem is still developing, but Innovate UK and Faraday Battery Challenge, very, very helpful to help those, in many cases, young organizations to come into proper existence. The support we have received is wide ranging. Part of this, what's the biggest obstacles to companies like ourselves, and I dare say probably the same with Luke's company, is funding. Funding is really, really hard to secure when this is a long-term transition. It's not something that's happening instantaneously, and nor will it give returns instantaneously. It's very, very hard to get funding, and we're very grateful for people like Faraday Battery Challenge, the Advanced Propulsion Centre, and the UK government as a whole for having faith in us and supporting us, because the consequences of failure are quite profound, where access to critical raw materials is growing in importance. Without those critical raw materials, we can't build electric vehicles. We can't build defense systems. Most defense systems now revolve around drones, we've seen recently in all the global conflicts. And the mining industry is very traditional, very conservative. But today, we've also seen, as well as this announcement in Canada, we've seen BHP bidding for Anglo American. Why? Because they're looking for copper. Copper is a critical raw material for electrification. And I think that this momentum of support for innovative companies in the renewable transition is growing. The obstacles that we've seen, again, largely revolve around access to funding. Getting funding for long-term projects is extremely challenging. We were lucky enough to build that support steadily, but it is not an easy journey. Many people ask me if I was completely sane, leaving a very well-paid investment banking job to go into something completely innovative and revolutionary. But it's been a fantastic journey. It still continues. It's extremely exciting to be involved in this transition, and I just think it's great. I would recommend young people to get involved in this, because it's exciting chemistry, it's exciting engineering, it's exciting electrical engineering. It's just an amazing revolution to be involved in. In 10 years' time, many of our children will look back and say, "Why were you driving around in a car with two chimneys sticking out the back?"
Yeah, no, really appreciate that, Jeremy. And on that note, I want to kind of bring us back. So we got about 10 minutes left here. So maybe we can kind of try to do a couple of questions. One of the questions from the audience is related to international collaboration. And specifically, I wanted to kind of zoom in a bit on that in the context of, collaboration between Canada and the UK. So maybe John and then maybe Thomas afterwards, you can talk a little bit about that.
Well, you might pick me. I used to work at Innovate UK as well a long time ago. So I have a reasonable understanding of the UK funding infrastructure and obviously Canadian. There are a couple of things that are happening today. So Canada is part of European framework horizon. Like UK is going back in. That's good news. So we can collaborate through the framework program, which is fantastic news and relatively recent for Canada to be a full member. There are mechanisms. Obviously, there's MOUs and trade agreements and all sorts of great things. I sit on the UK-Canada Joint Research Technology Council, which is a great vehicle to sort of explore opportunities between Canada and the UK. There is funding with Innovate UK, funding UK companies, and NRC IRAP here in Canada. There have been a number of joint funding programs. They've done about 2 a year. That is fantastic news. Innovate UK also has an incubator program, which they took UK companies and incubated them in Mars Discovery District. I don't know, Thomas, whether that's your that's one of you or ours, but incubating small SMEs that are looking to understand the North American market. So they're incubating in Mars Discovery District in Toronto in a very well-known sort of innovation central hub. So there's lots of individual pieces that have happened. In terms of UK Canada, there was a really interesting. We talked about it on our pre-call. There was a really interesting initiative looking at the solid state battery research initiative, which I think solid state batteries is really important. It's a topic that potentially we could collaborate on. I would say with the distances and weather and sort of geography that Canada has, the transition and the electrical charging infrastructure that Canada has, shift to solid state batteries are really important enabler to achieve some of these targets. Again, that was an individual, that individual moved on and that research agenda kind of sort of fizzled out. I think there's lots happening, but there's lots that could be done that could be embedded between our two countries and we're not competitive. We're uniquely strong. Automotive industry is a very, very important part of our fabric, but we're not competitive in terms of the way we're structured and the way the funding's flowing. There's huge opportunities for synergy, I think, between the Canadian model, which is really quite different to the way the UK has approached this sort of innovation and scale up.
Yeah, no, thanks, John. Really insightful there. Thomas, anything you want to add to that?
No, I think John's done most of my job for me. So thanks, John. No, I think to echo, I think it's, I said there are various initiatives that I was looking. I think some of them might have just shut a week or two ago, but there are general things that come out from the UK Canada sort of critical minerals agreements. I think that's something that the UK is going to be exploring more. I think we've had a recent change in our government structure, which means that our Minister for Critical Minerals is now in our Foreign and Commonwealth Development Office, which basically means the UK is going to go even bigger on engaging around critical minerals on a global aspect. And I think she's taking that as her mission moving forward. So that's really good. And I think in terms of how we're structured in the UK, we're quite joined up. So all of those initiatives that John's talked about all fall within the one organizational body. I think it's a matter of finding the right opportunities and having that voice in Canada that we can interact with. Because as I say, there's lots and lots of benefits. We are both, I like to say we're coming from both ends of the table. Canada with an awful lot of minerals, very strong automotive industry and a very growing sort of manufacturing supply chain. And UK, so the other way, we've got strong automotive industry, but a lot of research and development, a lot of expertise in that. There's a lot of synergies, and as I say, our export markets, our automotive markets are weirdly separate, but in a good way. UK, we pretty much 60% of our exports into Europe, very little into the US. I think it's sort of very low double figures. Canada, not sort of the opposite of that.
Thanks, Thomas. Luke, I see you want to jump in here, so feel free to comment on that.
Just to add that I think at the end of the day, the manufacturing supply chain will want to be regional. We don't want to be shipping things across the ocean. So at some point, we have to reach that state. Regional being, it could be North America, it could be, depending on how you define that. But then the innovation, this kind of value chain can very much be international, collaborative between different countries in order to get to the point where we have locally built up the expertise and the scale in order to fill in the missing link there of the supply chain. Just to add that.
Yeah, no, absolutely. And I think, Jeremy, from your vantage point, as kind of Thomas just highlighted, the need to kind of international collaboration on access to these critical minerals, specifically as from with trading partners and countries that have more secure relationships together. Any comment there on from your vantage point on the critical mineral collaboration piece?
Absolutely. I mean, I think, the UK government, I know, is collaborating with the Canadian government to try and secure supplies to the minerals that Canada has that we can bring over here to process. I think, I would love to say that the UK had all the critical minerals it needs for the energy transition. It simply doesn't. Canada's a massive country which has got a long history of extracting minerals. There's a huge amount of collaboration, I know, between our governments to work towards mutual processing and valorization of those critical minerals, so that less friendly nations can't get a hold of them. So, as I said, I think it's also not just towards transportation; it's towards defence. Defence is sadly become front of mind for all of us, and we have to have access to the minerals that go into batteries to enable us to defend ourselves against adversaries, which are growing in muscularity at the moment, which we really don't want to see. But no, there's lots of transit. We collaborate with firms in the US, with Canada, sharing technologies, trying to see if our technology or their technology is better for us. There's a huge amount of collaboration going on behind the scenes.
Yeah, no, for sure. So with a few minutes left, I just want to open it up for kind of final thoughts, final comments. Maybe start with you, John.
I'm just reading the chat. It seems you're sought after, Thomas. I'm bringing a small delegation of Canadian companies to the Cenex Expo in the UK, which is in September. So reach out. We're kind of mainly focusing on SMEs and companies that are interested in sort of collaborating and the UK market and sort of synergies. So I guess a final plug for that. Obviously, I'm very interested in UK, Canada. I think there's huge opportunity. I think the fact that Thomas made that comment that there's one body that you can go to in the UK, there isn't in Canada. I would say you've got Accelerate-Accélérer, who's got the voice, but our funding is very, very different here. It is fragmented significantly more than it is in the UK. So there's opportunities for us to sort of amplify that Canadian voice and look for those partnerships with the UK. I think nothing deep and meaningful there, just.
Awesome.
But thanks, Mo. It's been
John.
great. I've really enjoyed this. It's great to sort of speak to sort of ex-UK colleagues and be on this panel. So thanks for the opportunity.
Yeah, absolutely. Pleasure. Thank you for your time. Thomas.
No other comment. Fully encourage you to come over in September. But no, I think no, nothing from my side. So I think I put my message in the chat and think forward it on. But I think yes, I think first off, it's great. I think for Accelerate to put this on. I think we'll be continuing talks behind the scenes. I think, and I think we'll also see what both governments managed to achieve. I think as we progress through it. So there's a lot of government activity I know between Canada and the UK at the moment on critical minerals and on batteries. So I think watch the space for a little while.
Yeah, no, appreciate that. Luke?
Yeah, thanks for the opportunity. And just adding, I saw in the chat 2 points that we did not touch but are very important is people. So, for example, Northvolt want to hire 3,000 employees with almost a third of that as engineers. That's a lot of people that are not currently trained. So there's really that part of the ecosystem also that is important, and we're conscious of that. And recycling, of course, to second use in order to make the most out of it. So those are other points that are fortunately ongoing. So exciting times to come. Jeremy.
So, Jeremy.
Yeah, just I mean, I would just encourage anybody, young people listening to this. This is an extremely exciting industry to be involved in. It's right at the infancy. It can make a real difference by joining as a young engineer, young chemist, whatever. This is a massively exciting time. I just wish I was a bit younger and I could have got involved earlier. But no, hugely exciting. Thanks for having me on the webinar.
Yeah, absolutely. Thank you, Jeremy. Appreciate it, and appreciate all the work that you're doing. Maybe I'm just going to hand it over to my colleague Andrew to close us off here. But thanks everyone for joining. And Andrew?
Thanks very much, Mo, and I appreciate the very thorough and interesting conversation that you've led today. Thank you to all of our panelists for your time. I know, we could probably spend another hour getting into these intricacies of the connections in this emerging ecosystem. Appreciate all the time from our attendees today. We'll make sure that we do our utmost to kind of facilitate these connections. I know there's a lot of questions in the chat. How can I get in touch with Thomas or Luke or whoever? And part of our role here is to facilitate those connections. So we'll be following up with our participants, sharing the information, hopefully maybe address some of the questions that we were unable to get to on the webinar today. But thanks very much, everyone. Looking forward to continuing the dialogue in the future. And I hope that everyone has a nice rest of your day. So thanks for participating.